Hello, everybody. This is our analysis of algorithms group project using Heapsort. Our group members are myself, Zorne Corsi, Latyra Johnson, and Yulani Lowe. In this project, we had a similar problem that brought us together for the solution. We all have professors who need a method of finding the average grade for their students. We use this heap sort method to efficiently sort and generate the average grade of the students. This can also serve the purpose of letting students see their calculated grade. Overview. Majority of software today needs algorithms like these to sort large sums of data that must be processed in an efficient manner. This algorithm quickly sorts the grades or generated numbers in order to greatest to least. That list is then flipped to show an order of least to greatest. Heapsort takes the sorted numbers and heaps them together to generate the average. In this figure below, we illustrate how this works.
Yulani, and I'm going to be explaining the Heapsort algorithm. So, as already mentioned, we honestly all benefit from a program that tells us our average from the input that we give the computer. So we kind of just decided to use Heapsort to really quickly sort out the grades from least to greatest. So we can also see like where we were wrong at, or where we went right at. So I'm gonna first explain the steps of how Heapsort is going to work. So step one is going to scan from left to right of the array, from A0 to n-1 to find the largest. And then step two is going to exchange the following element with the last element, so A n-1. And step three is going to decrement, not increment, the size of the heap array by 1. So here on the side, I did an illustration because I feel like, in this class, really illustrating something is a lot easier to see how it works. And I did a sample of sample of random grades, and basically what the illustration is demonstrating is how the greatest grades are going to go to the left and the least are going to go to the right, and then from there it's going to then go into a new array and from least to greatest, and it will display the grades from there. And then of course in the main, that's when the grades, there's going to be an array in the main where it's going to add up all the grades while we are collecting the grades from the user, and then dividing it by the 5 grades by 5 grades, of course. So here I'm going to explain a little bit further the illustration. So the input numbers that I had was 80, 50, 98, 78, and 84. So what it does is it's going to start comparing, of course, from left to right. It's going to compare with 87 to 50. It's either going to stay the same, and then it's going to compare 50 to 98, and then it's going to move to the right, and then 98 is going to move to the left, and then so on and so forth. So that's basically what it's doing. And here are the arrows that I demonstrated of how the heap sort order is going to be. So yes, that is the algorithm. Thank you.
Here, we talk about our task assignments to delegate the tasks needed to complete this project. Each task was divided equally by each group member. After the tasks are assigned, weekly check-ins occur to ensure that each task was completed correctly. Below is a table with each group member's tasks. Myself, I handled the report and video script. Latyra, she handled the heap sort code, output testing, and video script. And Yulani, she handled the algorithm and video script. Next, Latyra will be presenting the code.
In our first function named org, we will practice the heapify procedure. This procedure will initialize the largest root, assign the equation to both the left and right child. This function will also call 3 if statements if the left child is larger than root, the right child is larger than the largest so far, or if the largest is not root. It will then at the end recursively heapify the affected subtree. Our next function will practice the heap sort method. It will first build the heap, which will rearrange the array. It will then one by one extract an element from the heap and move the current root to the end. Last, it will call the max org function on the reduced heap. Our last function is the print array function. This function will output the new sorted array. Here in our main, we will initialize the array size, prompt the user to enter the 5 elements. We will then take the 5 elements and put it into the array name A1, while at the same time find the sum of the array. We will then take the sum divided by 5 to calculate the average, call the heap sort function to sort the array elements, and output the new sorted array. We will also output the new average. Here below, we have an example of the code output.